voice, and talking. And we can say hello. How are you doing,
Hello.
Mama?
Okay.
What all have you been up to? It was the holiday weekend.
Went to a birthday party on Saturday for Ken.
Nice. Is that his second or third?
Third.
Third. He's
Yeah.
been. Yeah, because I remember. I think Ryan said that he was two. Um, while I was there, because I got there fairly late at the family gathering. So,
Yeah.
uh,
His birthday is actually, see what's today.
nice. I haven't been up to too much. Um, sort of continuing doing the things that I have been doing. Been planning on um, doing more games, so I'm going to try and stream more this week. I have plans for playing Project Zomboid after midnight on Thursday and Friday, or really early, just at the beginning of the switch over into Friday and Saturday. So on YouTube, it's listed as July 12th and 13th, but it is like 12:30 Eastern time for those days. But other than that, I haven't been up to too much. Yeah. Anything else before we start Sudoku?
Nah.
All right, then let's go ahead and get over to our first puzzle. Start recording, and the heat is on by Furba. Normal Sudoku rules apply. Place the digits 1 through 9 in each empty cell. Digits may not repeat within the same row, column, or box. Anti-entropy. No pair of orthogonally adjacent digits can contain digits from the same entropic set. The entropic sets are low, middle, and high. Low is 1, 2, 3, middle 4, 5, 6, and high 7, 8, 9. Ultra-fast thermometers. Along thermometers, digits increase by at least 3 at a time starting from the bulb end. Which basically means, hold on, I'm going to hit start puzzle. But that basically means that you have to be from one of each set in here. Because I cannot do 1 and 3 in the same set because those differ by only 2. And so that's going to be true for all of these. Which I guess I can speed that up just a little bit. Because even if I were to put, say, it doesn't matter. I guess I'm going to provide an example. So 1 plus 3 is 4, and we see that 4 is in the middle set, and then 4 plus 3 is 7, and that's in the high set. So that would be a proof of that. You start with the smallest from each.
Right. Now I noticed in box 2, 3, and 9,
Uh-huh.
the cell that's in the junction between the yellow and the red
Mm-hmm.
has to be blue, since you can't have in the same entropic set next to each other, if I remember correctly.
Right. Anti-entropy. No pair of orthogonally adjacent digits can contain digits from the same set.
Oh yeah,
So,
and in box 7, so.
yeah, so we can see all of those are blue. Well, that gives
And that
us...
is all the blue. So next to the red is yellow. Next to yellow would be red.
Right. And then yellow, and then red again.
Column 3 has all 3 blue.
which is going to place yellow.
Yeah.
But we don't know. Oh, wait, hold
Anything
on.
about.
There's only one yellow left. If I put that yellow here, then that would mean these two are both
Oh,
red.
right, yeah.
And the same problem occurs if this one were yellow, then these two are red. So that means that this one's yellow and this one is red. And that finishes that group.
Well, that one's either yellow or blue. We don't know.
Mm-hmm. If there was a red in this column, it would have to go here. Which means there would be no red up here. Which would make this one blue. And yellow.
Next to the blue would have to be. It couldn't. That doesn't work because that would have to be either yellow or blue, and it can't be either one.
So we know that this one isn't red. So we know that red has to be one of those two. But we know that this.
Since the center one in box 4 was not red, it has to be blue because it can't be yellow.
Right. And now that's all the yellows, so everything over here is, well, I need digits that aren't blue, and then a red.
Yeah, and column 2 needs one more yellow, which goes in between the... It's going to have to go there because the top one can't be yellow and the bottom can't be yellow.
Right. And
blue can't be next to blue.
Right.
And, okay, they need one blue. It can't be in the first or the second, or first or third, yeah. Needs one red, can't be next to red, and one yellow. And
that
that's
finishes
the third yellow for... Yeah.
So we get a red here.
We need one more red, and one blue.
Well, blue is done here. So this one has to be yellow. And there's one red and one yellow.
And yellow can't go next to yellow.
Oh, here. And so the red that's here has to be in this one. Why did I get confused about the... whatever.
No, that's blue.
Yeah. I put the right digits in, I put the wrong color in. Okay, well, I need a yellow here. It can't be either of those. I need a red. No, excuse me. I need a blue. It can't be this one. Spoilers. Blue, red, and yellow. Spoilers again. Honestly, I'm surprised to how infrequently that has happened. Neither of those are red, so one of those is. Oh, these are both different, so this must be blue. These are different, red. Can I ask anything about this column? I need one
It needs
blue.
one blue and one red. And it needs 2 yellow. Yeah, that just kind of became messy.
Yeah. Maybe this one? Because I need 2 red. And 1 blue and 1 yellow. I think it's the same as that column. It's not enough information. This row here. Where does red go in this row? It's not here, it's not there. So it's one of those 3.
All right, let's just say that the red in that row is in box 5.
Then I need yellow and
That
blue
has to
left.
be yellow.
This would have to become blue.
And so would the one on the left of it. And yellow is the
yellow
last
to
one.
finish.
Now, how does that affect?
So this would end up being red, because it's next to both yellow and blue. This would end up being red. And that finishes red. So this would end up being blue. This would become yellow. This one would be yellow. This would have to be blue to finish. Which seems fine. I've got all the blues,
And then it would
so we get a
need
red
2
here.
yellow and a red, and that still works. Okay, so red in box 5 works.
Okay, so let's check this one. This one becomes
Next to
yellow.
red and blue's yellow. Yeah.
And that would
And that's
finish the
all
red,
the
so
red.
this one's blue. And these are a yellow-blue pair.
All right, well, at the end of row 4, you have a red above and a blue above, so that would be yellow.
This one would be yellow.
And that would be yellow. Which is all the yellow in that row.
But now this can't be any of the colors. Because it's all the yellows in the box.
Right.
So this one doesn't work. And to make this one it, then
between red and yellow is blue. Between the corner there is blue and red, so that's yellow. That's all the blues in row 4. So it needs 2
yellow,
red and a yellow.
Red.
That's all the red in box 6.
But now I need 2 yellows to finish this box.
Right, so that one didn't work. Okay.
Okay. So this was all correct.
Yes. So now in the corners there in row 6. Fill those two in. Red and blue.
And blue and red. No, yellow.
Well, go ahead and finish in row. I was gonna say go ahead and finish the ones that are in row 7.
Red.
Because that's red and that one's yellow.
And then
Oh,
this
but yeah,
can't be
going
blue,
down the
right?
row, the column.
Blue and yellow and
That one's red or yellow.
oh, but this
row
one can't be
9
yellow,
has
so
all
this
the
one's red.
yellows.
I need one
That
more
row
yellow.
needs a red and a yellow.
A red and one more blue. Okay, so we got the pattern. So now we need to identify some fancy ones. So let's try this one, which let's make it stand
Well,
out
we
a bit
can
more.
probably get rid of all the color now.
That's true. So this is that one.
Box 7, or I mean box 8, you can get the green.
Right. Green. So one of those two is green. One of these two is green. So that makes this one green, and that one green. This one green.
Uh-huh. And we know either box 3 thermo bulb. Well, actually, none of them can be others can be green. So just pick one and give it a different color. And
so let's make this one purple.
Box 2, you can do the purple one.
Right. Purple and purple. And this one's purple now. And I guess I could also do the last one and make it orange. Because then this one's orange and that one's purple, which means this one's purple, that one's orange.
Row 5. Those are, yeah, so that one's orange, and those are green and purple, and the purple is resolved because of box 3.
Right.
Going down to.
And this one's orange, this one's purple. So this one's orange and purple. Okay. So then I guess maybe we do a middle.
Yeah.
Alright, let's start with this one. This one's going to be black. Black, gray, and silver. And actually, let's make this one black, gray, gray, and silver, because this one ends up being black, which means it's one of those two. One of these two. way. That makes more sense. It didn't have enough impact.
Well, we know 3 has to be followed by 6, has to be followed by 9.
Yeah. But we
Which
just don't
means
know.
2 would then have to be followed by 5, would have to be followed by 8.
Maybe it would depend on whether or not they overlap in the
How
wrong
many are,
way.
yeah, because they're not all 3. Yeah. But yeah, but 3 we know has to be followed by, and 2 of those are the same.
Yeah.
2 of those are purple.
Just trying to figure out which one would be the best one to like pick for, like we did with the green.
Maybe we have to go with high instead of mid. Because from box 1, the one on the right sees 2, in column 3 sees 2 in column 3 below it. Yeah.
Okay. And then we end up with these. Oh, red sees this one. Oh, and because this looks down here, red has to be one of these two, which takes it out of here. And then
Which
this one
takes
has to be
box
red.
9.
Has to be one of those two. And now it's both of those are out, so it's that one and that one. This one, not that one, not that one, this one. Okay, so that gave us red. Ah, yeah, see? Red is here and here, but the starts are different.
Right.
But
And the purples, purple cannot be 3 because 3 has to end with 9.
right, and this, if this was 9, it would have to be here, but it's not. Okay, so now the next one, let's make this one blue and yellow. So this one's blue, this one's yellow, this one's yellow, this one's blue. So yellow, blue, yellow, blue, yellow, blue, yellow, blue, yellow.
No, that one's blue.
Right. Blue and yellow. Alright. That was not systematic at all, but we got through it.
All right, in box 4, the top one sees in box 6, it sees 2, 4, 5, 6s. So we have that one's the same color. Yeah, that wasn't helpful at all, was it?
No. But we know that this one, if we make this gray, ends up having to be this one. So this one's silver. So this one's also silver. Silver's one of those two. Black, gray. Black, gray. Black, gray. Black, silver. Silver, gray. Black. Silver, gray. Gray. But this one isn't silver. So this one's black or gray. Black, silver. Any of the three? Any of the three? Black, silver, gray. A mess this is. I guess maybe instead we focus on this one. That one. This one. Because we know... Well, we know that one of these two has to be 6.
Right.
So this one cannot be. This one
And
and
either
that one.
red or yellow has to be 9. So blue cannot be.
This one is one of those two, so it has to be that one. This one is one of those two. So it's this one and that one. One of those two and one of those two. But it has to be this one. So it's not that one. So it's not this one, that one, or that one. Cool.
Well, sweet.
That,
That got all the black ones filled out.
yeah. So now this one's gray, that one's silver, so that means this is silver and gray. And gray and silver, and gray and silver, gray, silver, gray, silver, silver, gray, silver, gray, gray, and silver.
And gray, we know, cannot be 6.
Okay. So okay. Black cannot be 6 either, because if it was, it would be followed by 9 in 2 different digits.
Right.
Which means that gray is 6, red is 9, and orange can't be 3.
That was silver. You just made silver 6. Okay, yeah, that's right.
I meant silver.
Yeah.
I did say the
Yeah,
wrong
it threw me off when you said gray.
So that is those. So now black can be 5. But if it was 4, then orange and purple would both be 1. So black has to be 5, yellow has to be 8, and then 4, 7, 1, and 2, and we're done.
Nice.
Yeah. That was a rather difficult puzzle. But very, very good. I wish I had started the coloring from the beginning as the well, I don't know. Maybe it wasn't necessary
we needed to go through with the anti-entropy to get
to get the colors as they are now. So
yeah.
All right. Then I don't have anything else to say about this one. Do you?
No.
Oh, good puzzle. All right. The next one is Doggy Bag by Brave Den. Normal Sudoku rules apply. Colored areas contain no repeated digits. Along a green line, neighboring digits have a difference of at least 5. Along an orange line, neighboring digits have a difference of at least 4. A gray circle indicates a cell with an odd digit. Okay. Colored areas contain no repeated digits. Green lines are German whisper lines, difference of at least 5. Orange line is a Dutch whisper, difference of at least 4. Gray circles are odd. Okay. I'm ready.
Yep.
Guess I can start with odd digits here. And, well, the green digits can't repeat, so these two have to be the same. So these two don't share a 1. This digit is the same as that digit. One of these two is a 4. The other... Well, wait, hold on. No. This digit is that one. And this one is a 4. I kind of wish this wasn't the same color of blue as this group.
Yeah.
But, I mean, they're the exact same
put
size.
another color on top of it.
There, it's dark blue now. Oh, this and this can't be a 1 because it's in that region. And then 1 has to be one of these two, but this one is that, excuse me, these two are the same. So this is a 1, and that's not. This can't be a 5 because it's on the German whisper line. Difference of at least 4, so this is 8 or 9. And this is 1, 2, 3, or 4. I guess it could be a 5, but it's not 1, 2, or 4 because those digits are in the box. But it can't be a 5 because it's on the German whisper.
Right.
So 3. Take some stuff out. This ends up being 8.
So the German whispers are going to alternate high and low.
9.
And it can't have 5 on it.
5, 9, 3, 1, and 7. 7, 1, 9. This is now 5 or 7. This can't be a 7 because it's that digit.
Well, I guess you've got the German whisper that goes from the 2 up into box 2. You can at least, that's high.
That can't be a 4, so that's a 3, that's an 8, that's a 9. 3, 5, not a 5, that's a 5. Oh.
Column
these
9
two
has 1, 4, and 6 left. Oh.
6. These two red digits have to be these two digits here.
Right.
So, since neither of these two can be 9, this is 8. And this is 5 or 7, but because of the 5, this is a 7 and a 7 there. And a 7 here.
And box 6.
These.
Yeah.
9 is placed. 9's placed here as well. 6, 9, not a 7. This is a 6, so that's not. That's not.
So box 4, the white spot is a 6.
And then these are a 4-6 pair. So this is 1, the 6 places the 4, and then the 6 is placed. Oh. These two are the same, so that's a 6. 6 is one of those two, but I'm not sure which. This digit is 5 or 9, because it's that one.
Alright, the German whisper in box 4. If the top is low, it has to be 3. Because it sees 1, 2, and 4. And if
it was high, 7 or 8, because it sees 6 and 9, then the middle digit would have to be 2 and 3, because it can't be a 4, because that can't be a 9, and then this sees a 1 over here. So I guess we do the same thing over here. Low digits can't be a 4.
well,
and then
the top one sees 7, 8, and 9. So if it's high, it's a 6, but it can't be 6 because it can't go to 1.
Makes things easy enough. 7 and 8 are out. What's left over in this column over here? Column 6. 6, 2, 5, 3, and 8. Neither of those are 7. That's not a 1. Those aren't 1s. That's the last place a 1 can go. Not a 9. Also not a 6. So this is high. And apparently it sees, well, those are all high digits, so that's a 6. What's left over in the column?
2,
1,
3,
9,
4,
7, 8,
5.
6. 3 and 4 is out there, 2 is out there. Not sure if I want to look at those, but I mean, I guess I highlighted them, why not? 1, 6, 4, and 7. 8's removed from the bottom 2, 9 from the top 1. Which I guess I just noticed that 4 is one of these two. What's left over in this box? 1, 4, 5, and 7. Which none of these are 1, so that is. Four, 5, 7,
7,
9.
9.
So that's an
Leaves a
8,
2.
2. 2, 3, 4, 5, 7. 6 and 8. Um, 3, 4, 5, 6, 7, 8, 9. I mean, I guess it's all of those. It's not particularly helpful. I think we've mostly finished the colors. The only one that's still not done is these two. Which, I mean, it can still be a 5, because you can place a 5 here. I guess what's left in green? 1, 4, 9, and 5 are all out. These are all not 6. These 3 aren't 3. 2's out of these 2. 8 is out of all of those, so placed there, and that's not a 7. Well, this can't be an 8, so this can't be a 3, because you can't pair 3 and 7. Oh, 3, 7 pair is going to place a 5, I think. Takes 5 out of this one. 2, 3, 8, and 4.
4.
This one's not a 4, so that is. That's not a 4. I guess what's left in this row? 2, 6, 7, not 6.
1, 9.
Not 2, not 1 or 7. Two, 3, 5, 8, 9. So it's down here. 9, 3, 8, 1, 7. These two aren't 6. This is 4. That can't be 4 because we already said that 4 had to be one of those two. Because of that. And those being placed already.
Ah.
1, 2, 5, and 6, not 2 or 5. Oh, well that means this can't be a 6 now. Because if this was a 6, this would be a 1, and that would break that. So this is 2 and 9, which is going to place quite a bit of stuff around everywhere. 8, 3...
Well, that took care of
6,
box 4
8,
that I was looking at.
2, 9, 3, 7, 2, 6, 7, 1, 5, 7. 3, 4, 9, 5, 3, 2, 4, 7, 9, 5, 4, 7, 4, 4, 2, 3, 5, 2, 9, 8. What's left over in this row?
6.
And these two are 5 and
3.
3. That is it.
That was speedy.
Yeah.
Yeah, well, you got the one and got it in box 7. I was looking at box 4, and it's like, wait a minute, if it's 2 and 7 on the German Whisper, then the way it played out, you couldn't have anything in the 2, 7, 9, and 1 were all taken up, so you couldn't have anything in cell 8. But you saw what was in box 7, which took care of what I was seeing in box 4.
All right. I guess I'm not particularly fond of the name of the puzzle, but like, there's just there's only so many names, and I'm not exactly creative, so I guess I shouldn't. I don't have much room to talk here, regardless of whether or not I dislike the name. But I don't know. The way the puzzle's named has nothing to do with logic, and the logic was fun to work through. Next puzzle. Siphonophore? Is that how you would pronounce that?
Yeah.
Alright, hopefully that's correct. And this puzzle is by Voldemortensen. Feel a little bit more confident with the author's username. Normal Sudoku rules apply. Slow thermo rules apply. And I believe that slow thermos means that it must be greater than or equal to the digit before. So in this case, since this is a ridiculously long thermo, I could go 1, 2, 3, but then I can repeat 3 here. 4, 5, 6, 7, 8. As
that could repeat the 5.
Oh, right, yeah, 5, 6, 7. So that is the thing that is happening here. But in, I mean, I guess 1, 2, 3. This would have to be minimum 4, which would be a minimum 4 there. And all of those can be 4s, 5s, 5s.
No. Oh, yeah, because it can repeat from there.
Yeah. Then these are all 3, 4, 5, 6, no, 5, 6, 7, 4. This one cannot repeat because it sees where it's going. So 5. This would be a 6, but this one can repeat. 6, 6, 6, no, 7. Interesting. Um, 8, 9, 7, 8, 6, 7. But this could be 6, 7.
No, it can't be. Yeah, it can, because it can repeat the 7. Never mind.
5, 6, 4, 5, 4, 5, 3, 4, 1, 2, 3. 6, 7, 9, 5, 6, 7, 8, 4, 5, 6, 7, 4, 5, 6, 7. And that can't impact this. So let's go to this one. 8, 9, 7, 8, 7, 8, 6, 7, 5, 6, 4, 5. And then again, go to the end. 7, 8, 9, 6, 7, 8, 7, 8, 9, 6, 7, 8. Because if this was an 8, you got 9 and 8 here. Oh, but that would break this one, so this cannot be an 8. Because it has to have 3 digits that are strictly greater than it. Or 3 distinct digits that have to
be. It can't be 7 either. Oh, no, because that could be 7, 7, and that could be 8, and the last 2 could be 8 or 9.
Yeah. Yeah, it has to have 3 digits that are strictly greater than or equal to it. But this one can be equal as long as these 2 aren't. This becomes 5 and 6. That one's not impacted. But this is fairly tight in here. 3, 4, 5, 6. Oh, this is a 4, 5, 6 triple here, which is going to place a 7 and an 8, a 9, 7, 6, 5. This would have to repeat. This has to be smaller. 3, repeat. 2, 1, 3, 4, 5, 3, 4. But now that impacted a lot of things.
Right.
So to start out, 5, 6 pair, because those were set as to what they could be.
Right.
Has to be at least. That has to be strictly greater. This is 7, 8, 9, and well, that can't be a 7. So this is not a 7, not a 7. Okay. So now we work from the end here, 6, 7, 8, 9, not 7 or 8. Not a 4, or rather, it was minimum 4, so we put in all of the options, not 4 or 7, and that bubbles up to the top of the thermo. And so now this becomes 5, 6, 7. Could be 8 if it slow thermoed up to here, but this cannot be a 3, 4, or 7. So that means this is not a 4 or a 5, which means this cannot be a 5, but it could go 6, 8, 9. But this one cannot be a 6, so it has to be a 9.
6, 8 pair in the box.
Right. Although I don't think that influences anything. Not at the moment,
just the box.
At least.
It also affected the fact that that's a 9 and not.
Yeah. So that came down to here. So this can be. Well, it can't be a 4 anymore. It's minimum 6. But then we go here 6, 7, 8, 9, not a 7. 5, 6, 7, 8, not a 7. But before it is
minimum 6.
So 4 and 5 come off, so 5 and 6 come off as well. 6, 8 pair makes this a 9. Okay, this cannot be an 8, because these have to be a 6, 8 pair. So 8 is out. And I believe 7 is out as well, because one of them has to be a 6. So this is a 6, that's a 5, that's a 7, that's a 7, not a 6, 5, 6. Doesn't impact any of that. Okay, I think that's correct so far. So then we've got 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, not 7 or 9, 4, 5, 6, 7, not 6 or 7, 3, 4, 5, not a 5, 3 and 4, not a 4, 2 and not 3. Okay. I think that's all the things. Oh, I guess the 6, 8 takes 6 and 8 off of that.
That's what I was
takes 5 out, takes 4 out. But then we're good. Alright, anything else that you see?
No.
Okay, and then I think across here is 1, 2, and 3 with the 3 out of here. so that places a 3 there. 1, 2, and 6, which is, that one's not 6, so that one is, which is going to place all of these. What's left over in here? 1, 2, 3, and, well...
8 and 9.
8, 9. 8. Uh-oh. Wait, hold on. 1, 2, 3, 8, 9. There we go. This is not 8 or 9, so that's a 1, 2, 3 triple. 1, 2, 3. That can't be 9, so that is placed like that. I got ahead of myself through here, which was not the best play. 1, 2, and 5. And 1, 2, 3,
4.
and the 3s are out. 1, 2, 3, 4, and 5. Not a 1 though, which I guess places a 1. And 2 and 5 makes that a 4. I guess the 2, 3 does the same thing.
Column 1 has 2, 3, 4.
2, 3. Column 4 has 4 and 5, I believe. Makes a pair there. How about column 6?
1, 2, 3, 4. And 9. No, not 9.
Yeah. 1, 2, 3,
1,
4,
2,
and that's
3,
all
4.
that's left over. So 4 is placed up here. Takes that out, that out, that out. Those aren't set yet. These 2 are missing
8, 9.
And those are placed because the 8 over here. And then 2, 3, and 6, which is actually placed. 1, 2, 3 triple. Okay. Where next? Box 1, maybe? Why not? 2, 3, and 4, and 7. 1, 5, 8, 1, 6, 8, 6, 8, 9, 5, 8, 9, 5, 6, 9. Oh, only one place for an 8, because there's 2 8s, and that has to go down here. This 8 takes it out there, and 7 is not 8, so we get an 8 there. So row 3, 2, 4, and
1.
1. So that one's not a 4. And not sure. I guess row 2. 1, 6, 5, 3, and 4, and that should be all of the digits that we're missing. 3 and 4 is out of here, which is going to make a triple, so 1, 5, and 6. 8 and 4 are out, so are both 8 and 9. Wait, hold on, I did something wrong. 1, 8, 4. 1, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 8, and 4, and 9. And 3, and 6, 7. Kept pressing the wrong buttons for some reason. Okay.
Well, no, either way, it's one of those 2. Row 7 needs a 4.
It's not here.
And the 4 in column 7 has to be down there in box 9.
Right. So the 4 is here. And we still have 1, 2, 3, and 6 left over, I think. 3 and 6 are out of there, so that's a 6.
Oh, I thought, never mind. I wasn't looking at the row, I was looking at the box. It's like, no, there's a 6 there.
But these 3 are not 2, 3, oh, wait a second. Oh, we got the 4 out of here. That's what forced a 4 here.
Yeah.
So, but we don't know between 2, 3, and 5 what's left over. 6 is out of box 3. So I guess that's lots of digits, but not 4, 6, 8, or 9. These two aren't 7, which actually places as 7, and this one isn't a 3. 3 here. 1, 2, and 5.
Triple.
Places 6 and 7. Takes the 7 out. 1, 5, 9, 6.
All right, well, let's look at column 2. 3 and 5? No, 3 and 9.
Which are placed because of the 9 over here, which is going to fix these. And do quite a bit of stuff. 2, 3 pair makes that 5. Don't think that does anything fancy. 2, 5, not 5. And that's about 1, 3 pair. Gonna fix the rest of that. Here.
Row 8 needs a 1. Oh, okay.
And the last digit is a
8.
Yeah, another
that
speed
one was
puzzle.
82.
Yeah, I do like the slow thermo rules. Like that was really interesting to kind of work the way down and back up, and how it would influence the puzzle.
Mm-hmm.
Oh, this one ended up being just a standard thermo. But yeah, that one was good. Even if I can't pronounce the name. Alright, puzzle number 4 for today is 10 Types of Lines by Math Pesto. If I remember correctly, we were in the middle of this last time, and we actually should have started with that, but I didn't mark it correctly in the bookmarks. So, return to this puzzle from last time, because this one is hard. 10 types of... And also, I guess we were sleepy, and...
It was also... we went ahead and started it, even though we had like a half hour or so, 20 minutes left.
Yeah, we didn't have a whole lot of time, so it was after we'd used our brains quite a bit, and it's always the time of nap, so... All right.
And we had probably already gone past 10, so...
All right. So, 10 Types of Lines by Math Pesto. Normal Sudoku rules apply. Digits in a circle appear at least once each in the 4 surrounding cells. From left to right, top to bottom, the following lines of the following properties. Whisper, green, adjacent digits differ by 5 or more. Thermo, gray, digits increase from the bulb to the end. Renban, purple, the line contains a set of consecutive digits, not necessarily in order. Between, gray, digits on the line are between the values in the circled ends. Region sum, blue, digits on the line have the same sum in each box the line is in. 10 line, gray, the line consists of 1 or more contiguous groups of cells, each of which sums to 10. Groups cannot overlap. Nabner, yellow. No 2 digits may be consecutive. Parity, red. Adjacent digits alternate between odd-even parity. Modular, black. Every set of 3 sequential digits contains 1 digit from 147, 1 from 258, and 1 from 369. Entropic, orange. Every set of 3 sequential digits contains 1 digit from 123, 1 from 456, and 1 from 789. Alright, let us resume this puzzle here. And if I remember correctly, this 10 line, we had determined that it had to be 2 groups of 10. So where are we from here? I don't remember how we ruled. Oh, we ruled 3 out of here. Okay. So, up here, the reason we can't do, um, 3 in this group is because we know that these are 2 pairs of 10. So we've got 25 here, but that also means that this is 20, here, as the sum of these 4 digits. Which means, because this is a pair of 10, and this is a pair that sums to 10, that the last 4 are 2 pairs that sum to 10. In which case, if I were to put a 3 and one of the 2 low digits, it would be paired with 8 and 9, and then I wouldn't be able to use 3, 7 down here, which would break it. Or rather, if the low digit was one of the middle ones, I can still do 3 and 7 on the top and bottom. But that takes 3 out of the middle. 4 is automatically out of the middle because it would be 4 and 9. 4 and 9s on either side, on both sides. So that left 1 and 2 as the possible low digits. 2 was removed by these 2 quadruples. So you couldn't put a 2 over here. So we know 1, which has to pair with 9, is placed in here somewhere. We don't know where, but we know it's up there. And then either 8 or 9, which is going to pair with, then the other high digit could possibly be an 8 if it's in the middle, as the middle high digit, which would pair with a 2 as the other low digit. Which I guess, if this is a 1, well, no, because that could be a 9, and then there's nothing stopping this from being a 3 and a 7. But if this is 1 and 8, then we get 9 and 2. But I don't know if it means anything to really place that, because I could put 4 and 6 on these sides, too. There's nothing stopping me in that regard. But, okay, so where do we go from here? Why can't this be 6? Oh, I know why it couldn't be 6, because that would be all of the low digits, and the entropic line below it has to have at least 1 from the digits 1, 2, and 3. Which means that this digit here and the 2 green ones are not from 1, 2, and 3, but green and purple are also from different sets, because at least one of these 3 has to be from the middle set, and 1 from the high set. So I've already used the other green digit somewhere up here. So this one's purple. So that was the logic there. Hmm. This line, the yellow one here in the bottom left corner, or the bottom of row or column 3, excuse me, is a Nabner line, which means that it doesn't have any consecutive digits. We know there's an 8 on there, which means that we don't have 7 or 9. And so going up from 1, I could go 1, 3, 5, and be just fine. Or I can skip a digit, and I could go 1, 4, 6, 8, or 1, 3, 6, 8. So if you go 1, 3, 5, 8, 2, 4, 6, 8, 1, 4, 6, 8, or 1, 3, 6, 8. But there's no way to know for sure, I don't think, as to which one is which. But I do know.
Oh.
I could just hear you now. So if you were going over anything, then I couldn't hear before.
Well, no, because can you hear me? And so I unplugged it, I replugged it, I restarted the thing, and it's like, you still can't hear me. And it's like, oh, wait a minute, did I accidentally mute it somehow? Yes.
What were you wanting to or trying to say?
Well, I couldn't remember what the black line was.
The black line is it's a modular line. So each digit has to be from 147, 258, and 369, and they're from the modular sets mod 3.
Right.
So 1, 4, and 7 all have remainders of 1 if you were to divide by 3. 2, 5, and 8 remainders of 2, and 3, 6, 9 are all divisible by 3. Okay. I'm not certain where to go from. I know that the red line is a parity line. It alternates odd, even.
Right.
The purple line is a Renban line, which means all of the digits are sequential, or rather consecutive. They're a consecutive set. They don't have to be 4 in order. They could go 1, 4, 3, 2, and be just fine. And a sequential set like that, or a consecutive set, has to alternate odd-even as well. And so we know the digit in the middle of the column is odd.
Right.
But I don't know if we get any additional information because of that. Because the odd evenness doesn't have any direction to it, if that like feels like it makes sense. Like you don't like just because like if I were to put like a 3 here, that doesn't mean anything about these except they're 2, 4, 6, and 8. So and because the Renban is length 4, it doesn't even require any overlaps in digits. Like it could be 1 through 4, it could be 9 through 6, and neither of those groups overlap. If it was one longer, it would have to have a 5 on it, but it's not one longer. And I don't think even, like, if this was a 1, the fact that these two quadruples prevent 2 in the middle, I don't think that prevents this from being 1 on the outside and 2 above. Or vice versa. You could put a 1 here and then a 2 on the outside, and it'd be just fine. So what are we missing?
I'm not sure what we're missing.
If this was a 4, how does that impact the Nabner line? Because it's the possibilities, because of the 8, are 1, 3, 5, and 8. Or I can skip a digit, because I can do 2, 4, 6. I can do 1, 4, 6, or I could go 1, 3, 6. But it has to be 3 non-consecutive digits from 1 through 6. And because 1, 3, 5 and 2, 4, 6 completely overlap, or rather have no overlap, I mean, I guess if I were to place a 4 here, then this is 5 or 6. I would have to have 1 and 3 if this was a 4. It would have to be 1 and 3. Because the consecutive... Okay, so what I just realized is the non-consecutive digits is from 1 and 2, 3 or 4, and 5 or 6. So if I make a 4, then the 3 or 4 pair, or digit, on the Nabner line would have to become a 3, which eliminates 2, so the 1 over 2 has to be 1. It's the 5 or 6 that's left over. This would end up being 5 or 6, so that is done. This ends up being 7 and 9. So that could still be a 4. But what if this digit was a 6? Well, this couldn't be 5, so it would have to be 2, 3, or 4. And this would have to be 1 or 3. I'm not sure, but this cannot be a 2, because I have to have 1 or 2 on this line. It cannot go 3, 5, and then something, then 8. So we don't have a 2 here. And that means this is a 2-8 pair, which means that this is a 2-8 pair. And now I don't have 1 or 2.
And that puts a 2 on the between line in box 3.
That is correct. So then one of these is a 1. Okay, but now, knowing the 2-8 is removed from here, I cannot put 2 or 8 on the top of the 10 here, the 10 line. So I have to have both 2 and 8 up here. So this has to be 1, 8, 9, and 2. So this is 3, 7, 4, and 6. And we have made progress.
So in box 7, 1 is one of those 2.
That is correct. And 1 is one of these 2, so we get 1 is one of those 2. Oh, we know 1 is one of those.
Since 2 and 8 is on the Nabner line.
Oh, we don't have 3.
Not be on there.
So we know we have 4, which means we don't have 5. So 4, 6 pair means this cannot be a 4 and 6. This cannot be a 3 and 7. But we don't have 4 and 6, and 2 and 8, just to make sure those are all off. And then this is 1, 4, 6.
Now the top of the thermo
can't be a 5.
Oh. And those are all odd. All of the evens are on the Nabner line, so that's... Wait a minute. In box 7, below the 9 is a 1-5 pair. Because there's a 4-6 pair and a 3-7 pair and a 2-8 pair in the...
Right. Thank you for catching that. I missed that one pretty badly. Alright. Well, what that means is that one of these is 5. But I guess we already knew that.
Yeah.
So then... Well, 4 and 6 means this isn't 4 and 6. Okay, but this digit of the Renban is no longer 1 or 9. Because if it was 1, you'd have to put a 2 in here, but you can't. And if it was 9, you'd have to put a 9 up here, which you can't. However, you can still put 1 or 9 inside of the box.
Right.
You just put the 2 and the 8 on the outside. This cannot be 2, 3, 4 now, because you can't have a 2, which means you can't be 7, but that means it has to have a 1. So this is 1, this is not 1, this is 3, 1, 5, 7, 9. None of these are 9 now. 2, 9, 8, 6 is out, and...
Well, the German Whisper can be completed.
Oh, here. 1, 8. And no more colors. 2, 8. 2 and something, but that's not the one. 1, 3, and 4 means those are.
Oh, well, the
8s.
7 for that can be placed, though. Because there's a 7 in row 2. The 2, 7 circle.
Right. And now we get 3, 4, 5, 6, 7. And it can't be a 9 on there. It also cannot be 3 and 4 due to this. So this is minimum 5. So this is 6 through 8. Not a 9 because of the 9 in box 1. And then I guess what's left over here in the middle, 1, 2, 3, and 4. Not a 9. Neither of these are 7 or 8. This isn't a 5. 5, 6, 9 triple takes 6 and 5 out and get a 7, 8 pair. And this cannot be a 3, so that is. So the 3 there takes it out of those. And those 2 are removed. So one of these is a 2. Because we have 1 and 3.
Okay, so the 2 in row 9 is going to be in box 8. And it can't be...
One, 2, 8, 9, 7, 5. 2, 7, 8. 4, 6, or 9. But we don't have 8 on here anymore. Or excuse me, we don't have. You can't put 8 on the top 3, and this 8 removes it from the bottom. So it's not possible to put 9 on the Renban, and this 9 removes it from here, and none of those are 9. So that's a 9. That's not. 5, 6 pair makes that a 9, and 9
there
ends
now has to be a 4 on the Renban. But I guess you kind of knew that.
Yeah.
Oh, and since it has to have 2 evens and 2 odds, well, no, because the other can be on the outside. On the outside.
Yeah. But this 9 is given because this ended up being a 9, so I had to place at least one 9 down here. It's neither of those two, and this one takes it off of that one. So this was the the black line is a modular line, so 3, 6, and 9 is all removed. From these, 1 and 2 is removed, and 8 is removed. 4 and 7 are in the same group, but 5 is not in that same group, so we don't know how orange goes. This one isn't a 9. Which means if it's a high digit, because the orange line here is a tropic line, if this is a 7, then this one up here is a 9. And if this is a 5, then this one down here has to be a 6. Two, 5, 6, 7, 9, not 9. Four, 5, 7, 8 means this one's 6, this one's 5. This one over here is not a 6, and I think 3 is the leftover digit that I don't have in that column. And
oh, in box 9 on the entropic line, one is low. The 2 center ones there, one is low and one is purple. Purple is high. So
not necessarily.
It can't be 5. Oh.
Because purple could be 6, which is a middle.
4, 5, 6. Right. Yeah. Sorry.
4, 6 pair takes a 4 out of here. And actually, what's left over here in box 6? 1, 3, and 8. And none of those are 9 or 5. And this isn't 4 or 6.
Row 2 has left 1, 3, and 4.
2, 1, 3, 4. Oh. Well, you said that 4 had to be on the Renban, right? So, if that's a 4, that's a 6. But that doesn't necessarily... I mean, this probably ends up being a 7, because 2, 7, 8, and 9 are out. I guess let's fill in them. 2, 8, 9, 7. Say again. 7, 6, 5, 4. Which works.
If the center digit was 4 of box 2, if the center of box 2 was 4, then that's a 4, 6. Those are the 2 evens. Then the 2 odds are on the outside, and the only 4. It
You
could
can
be
do
5 and
5,
7, or
7,
3 and 5.
yeah, 5 and 3. I mean, I guess I need to fill in box 5. Guess let's go across the rows. 9, 3, 1, and 8. Not a 2 and not a 7. 5, 1, 3. This one, 7, 9. Not 2 or 8. And we don't have 4 and 6 in the row because of the 4, 6 pair. This one isn't 2 or 8. This one isn't 7 or 9. But that isn't enough information. I guess 5 is out of this whole column because it has to be one of these two because of the quadruple here. Where can 5 be in this group? It's not down the middle. It's not down the middle this way, and it's not 1 or 8. So 5 has to be one of these two. So that takes 5, well, out of these two here, really. So where is 5 in this box? It's not on the bottom, it's not here, and it's neither of those two. So 5 is either here or there. I mean, which is fine, because 5 is one of those two up there. One of these two, one of those two, and then literally anywhere in this box except for there. Not down the middle. Okay. Well, if this is a 5, then this isn't a 5. And if this is a 7, then this one isn't a 7. Yeah, if this was a 5, this would have to be 2 or 8. And if this was a 7, this one would have to be 1 or 4. So that limits...
the two orange ones.
Yeah.
One, it's going to have to be a 7 or an 8 included in that. Which goes with the 7 or 8 at the top of the column.
So this one isn't 7 or 8, it's 4 or 5.
Okay, so the center column of that box, 1 and 3. Everything else is accounted for, but we know 1 and 3 have to be in there.
Yeah.
Oh, but 5 has to be on the entropic line. Because, oh no, it doesn't have to be.
Yeah.
Well, it does, but not in box 9.
Right. Where is 9 in this box? It's not here, it's not there, and it's not there. One of those two is 9. Is there anything that we can force onto the odd-even line?
8 has to be on there.
No, 8 has to be one of these two digits.
Well, no, but look at the rest of the column. It can't be on the Renban.
Right, so this is 8.
So that has to be 8.
So this is 2, 4, or 6. You can't put a 2 here. This one's 2, so that's not a 2. These aren't 8 or 2. That's not a 2. That's not an 8. 2, 7 pair places an 8. 2, 7 takes that 7 out. Oh, and the 5 out. 4, 8, 9, and 5 and 8 are in the same group, so that's good. 9, 7. So that places a 6. 2, 5, 6s, 4. Oops. This is 4, 7, 8, 4, 4, 4, 6, 9, 1, 3 pair, 7, 9, so we place a 6, which is a 5, a 2, wait, hold on. Yeah, 7, so that is a 2.
Yeah, 7.
6. That ends up being a 5. I just hadn't completed the logic there.
Okay, the even, the Renban.
Mm-hmm.
Since 2 is on there, 6 cannot be.
So that's a 4, and this has to be a 3.
And a 3.
1, 6, 4, 6, 3, 4, 1, 7, 2, 3, 1. This is a 6. That's not a 3. That's not a 3. Okay, and this is 8 and 3. And 5, 7, 9, and 4. Except neither of those are 4. So that is not a 9, not a 7. 1, 5, 7, 9. I think that is good. 1, 5, and 9 means that's not a 1. So this is, well, if it's not 1 and 3, 6, as you said. This is a 1, 3 pair.
The circle there between box 7 and 8, that's a 5.
1, 7, 7, 9, 2, 5, 1, 5, 8, 2, 3, 8, 3, and 1, and we're done. That was a very hard puzzle, but it was still good. I think the really important logic that it took us a really long time to see was how the Nabner line, once we got the 8 on there, how the rest of the digits were 1 or 2, 3 or 4, and 5 or 6. And in those, like, two... I'm not sure exactly how to describe them as, like, sets as they are, but and how that influenced what was going on up here. But yeah, and then there was a lot of other like nitpicky stuff as we went through the puzzle, but other than that, I'm not sure what else to say. I definitely enjoyed that one. Any comments on this puzzle before we probably sign off, because we've got 12 minutes left, unless you want to start another one.
If we knew we could get another quickie like this.
Yeah. I'm not sure this one is... I think this one's not a...
I don't think that's going to be a quickie.
Yeah, this one's a different type of puzzle. So I think what we do is we just say this was the end. I did hit like on all the puzzles, I believe. I sure did. Alright, then. Anything else to say about the puzzles, Mama?
No, oh, somebody waved. Oh, it's Triple Z.
Yep. I did miss those comments from earlier. Some waves and some big brains. Appreciate the comments, ZZZ. One of these days I will get a second monitor instead of trying to rely on my phone, which I forget exists. And I will have an easier time seeing the comments. I guess I don't need to be recording anymore. But yeah. As I said, I will try to be streaming more this week. Try and do random stuff. Usually going to be quite late. In fact, I'm going to try to stream something later tonight. After we sign off from here. And then I have streams tomorrow's more Sudoku with Mama. And then I have Project Zomboid with a friend of mine on Thursday night after midnight, which means it's Friday, and Friday night after midnight, which is Saturday. So I did put those on the schedule as July 12th and 13th because they're Eastern Time, 12:30 Eastern Time, at AM version, so it does sort of feel more like it's Thursday night and Friday night. But other than that,
I suppose you could always say 0:30.
That's true, 0:30. Although I have heard a significant number of people complain about 24-hour time, so it's I don't know. I've always found it quite simple, and I've always recommended subtracting 2 and then 10, because I found that to be an easier way of going about it than trying to just wholly subtract 12. But it is what it is. Yeah, alright. Any final commentary, Mama, before we sign off?
I don't think so. I think I'm just, kind of here.
Yeah. And I appreciate it because I don't think I could do all of the puzzles without you. It's definitely a lot more fun with you. Exactly. It would take me a lot longer to see some of the things. But yeah, other than that, I believe that is the end of the stream. Thank you for watching. If you haven't, make sure you like, comment, and subscribe. And all that other fancy YouTube algorithm engagement stuff. Share the video with everyone that you know. And goodbye for now.